With a slender body and shimmering silver scales, the mackerel glides silently through the blue water. Seemingly harmless, yet a high-performance hunting machine. This very predator brings in over 5 million tons each year, becoming a familiar dish on dinner tables in millions of households around the world. Yet what's truly remarkable is that the mackerel isn't just a formidable hunter. It's also a vital link in the global food chain, generating over $6 billion in economic value each year. From shimmering silver mackerel swarms swirling like living ribbons in the deep ocean, each fish is hauled onto the deck while still plump and gleaming fresh. Within hours, they enter modern processing plants and are transformed into tempting products. From golden salted fillets and glossy teriyaki glazed cuts to neatly packed export-ready canned mackerel. Today, join Agriculture Insight as we step inside some of the world's most advanced mackerel processing facilities and uncover the intricate journey behind each delicate, high-value slice. Everything will be revealed in this video. If Japan is the mackerel processing factory of the world, responsible for about 25% of global processed mackerel output, equipped with modern production lines and a wide range of exports across 5 continents, then the United States is the consumption giant, spending billions of dollars each year to import mackerel for a market that demands high standards in quality, flavor, and nutrition. Mackerel isn't just a fast swimmer, it's a finely tuned predator of the sea. When schools of prey like sardines or shrimp enter its strike zone, mackerel swiftly join forces, spiraling into a vortex that devours everything in its path. But would you ever guess that the rich, flavorful slice of mackerel on your plate might be hiding a reservoir of mercury? Deep within that savory flesh lies the consequence of a long chain of bioaccumulation passed on from one tiny prey to the next. Eat it too often, especially king mackerel, and you may silently cross the threshold of safe consumption, with no symptoms, no warning signs. Yet, despite the warnings, the journey of bringing mackerel from the deep sea to the dinner table shows no signs of slowing down. Humans continue to pursue this high-speed fish across shifting currents and the last pockets of cold water in an ever-warming ocean, fueling a year-round global hunt. And every journey has a beginning. Join me as we set sail for the Atlantic, where specialized fishing fleets power through the waves, launching an epic chase called Mackerel. From May to October, the ocean enters its golden season. Shifting currents push young sardines, shrimp, and squid toward the surface, drawing in the shimmering silhouettes of mackerel, the speed hunters of the deep. In this modern hunt, no method is more effective or spectacular than the purse seine. A massive net, hundreds of meters long, dropped into the water to form a tightening arc, a near-invisible trap in the open sea. Speed is critical. The faster the net is cinched, the slimmer the chance of escape. As the final line pulls tight like a steel noose, tens of tons of glittering mackerel are captured in a writhing mass of silver beneath foaming waters. Giant cranes roar to life, lifting heavy hauls one after another into refrigerated holds kept near -20°C to lock in freshness. In less than 30 minutes, a single haul can bring in over 200 tons, an amount that once took an entire coastal village weeks to gather. It's not just a triumph of technology, but a relentless contest between humankind and the sea. But mackerel don't always gather in dense schools. When they scatter, dive deep, or swim to remote offshore waters, fishermen must change their strategy. Instead of chasing the crowd, they patiently wait for individual fish, using the longline method, an art that demands precision and persistence. Across the vast ocean surface, a main line stretching for dozens of kilometers is deployed, carrying thousands of dangling hooks, like invisible traps suspended in the deep. The bait is fresh squid, sardines, or shrimp. irresistible treats that trigger the mackerel's hunting instincts. When a fish bites, each glistening silver body is carefully hauled in, unhooked, and placed directly into chilled storage. No bruises, no scratches, preserving its ocean-fresh quality as if it had just left the sea. As soon as the boats dock, a portion of the mackerel is unloaded at the wholesale fish market, where lively auctions begin before dawn breaks through the mist. The rest heads straight to processing factories, flowing through a network of chilled pipelines running beneath the port like its very bloodstream. At the factory, mackerel are guided into an automated sorting system using stainless steel chutes. As the fish slide down, smaller ones fall through the gaps between the rails and are redirected to a separate processing line, primarily for canning. Larger fish remain on top and continue to subsequent stages, such as filleting, marinating, or being frozen whole for export. This system enables preliminary size-based sorting right from the intake, optimizing the production process, reducing the load on later stages, and improving overall processing efficiency. Right from the initial stage, the mackerel pre-processing line demonstrates near-perfect precision. While traditional manual methods of decapitation often result in millimeter-level errors, enough to tear the skin, lose valuable meat, and reduce product value, here, each mackerel is neatly placed into a shaped mold and precisely aligned using laser guidance with an error margin of less than 0.5 millimeters. This allows the blade to cut exactly at the junction between the head and body, producing a clean, sharp separation as if machine molded. The entire process operates at a speed of several hundred fish per minute, enabling the plant to handle tens of tons per shift while maintaining exceptional consistency and precision. Next, the fish body is immediately transferred to an automatic filleting system, where blades are programmed to optimize meat yield. No excess, no waste. For specimens with a fat content exceeding 20%, the system automatically divides them into 3 proportionate portions, maintaining both structure and richness, something nearly impossible to achieve by hand. Importantly, none of the removed parts, heads, guts, or backbones, are discarded. Instead, they are repurposed into raw material for aquaculture feed, creating a closed-loop system where no part of the mackerel goes to waste. Although mackerel is not known for having many fine bones, processing plants still carry out an additional bone removal step after filleting to ensure top quality. In many facilities, this task is still done manually under intense white lighting. The fillets are placed on chilled stainless steel tables, where workers use specialized steel tweezers to carefully extract even the smallest bones, as leaving just one could result in the entire batch being rejected in strict markets like Japan or the EU. However, in modern factories, this step has been replaced by dedicated pin bone removal machines. The fish meat is passed through mechanical rollers that apply just the right amount of pressure, enough to dislodge the bones without damaging the flesh. After bone removal, the mackerel fillets are given a final rinse, neatly arranged, and moved to the light salting stage, a key step to stabilize the flesh structure and extend shelf life. First, the fillets pass through an artificial cold rain system, a chilled water spray that provides preliminary rinsing, removes surface protein residues, and cools the fillets before salting. Next, a low-concentration brine spray, 2–3%, is applied. This salt layer isn't meant to make the fillets noticeably salty, but is just enough to firm the muscle fibers, neutralize mild fishy odors, stabilize flesh color, and create a natural biofilm that helps retain freshness during freezing. Each fillet is then precisely placed onto stainless steel trays, with spacing calculated down to the millimeter to ensure even cold air circulation. This arrangement prevents sticking, warping, or deformation during freezing. Finally, the trays are transferred into a blast freezer, where the temperature drops rapidly to -35 to 40 degrees Celsius, combined with strong, cold airflow. Within minutes, each fillet reaches an ideal, deep frozen state, firm, evenly colored, and ready for packaging. However, not all mackerel is destined for frozen packaging. A portion continues its journey to a more specialized production line, where the fillets are transformed into the famous teriyaki grilled mackerel. On the teriyaki grilling line, filleted mackerel portions are neatly arranged on stainless steel conveyor belts and slowly pass through a modern roasting chamber. Instead of using direct flames, superheated steam at around 300 degrees Celsius is circulated through the chamber, allowing the fish to cook evenly from the inside out without drying the surface. After the initial roasting, the fillets move on to an automatic teriyaki sauce application system. Here, a sauce made from Japanese soy sauce, mirin, sugar, and ginger extract is evenly sprayed onto both sides of the fish. Rather than marinating in advance, the sauce is applied near the end of cooking, a technique that helps it cling tightly to the surface, forming a glossy caramelized layer when the fillets return to the roasting chamber for a final round. If salted mackerel represents the traditional flavor of the sea, then canned mackerel is a modern evolution, compact, sustainable, and ready to conquer global markets. The process begins with medium to large-sized mackerel, which are cut into segments measuring 6 to 10 centimeters in length, matching the standard height of each can. A stainless steel blade is precisely positioned over the conveyor belt, lowering at regular intervals like a metronome, slicing the fish into clean, uniform sections with millimeter-level accuracy. After the pre-processing stage, fresh, fatty mackerel portions are transferred to the canning area. Depending on their size, each can holds 1 to 3 pieces, neatly arranged either vertically or horizontally to optimize space and minimize shifting during cooking. Once arranged, the cans automatically move to the liquid filling system. The filling nozzles move in a steady, rhythmic motion, dispensing a smooth, glossy stream of liquid into each can of mackerel as it moves along the conveyor belt, just enough to fully cover the fish without overflowing. Depending on the product type, this liquid may be vegetable oil, light brine, tomato sauce, or a specialty blend such as teriyaki or a thick, chocolate-colored brown sauce. Despite their different formulations, these liquids share a common purpose: to act as a natural preservative while infusing the fish with flavor during the high-pressure sterilization process, enhancing both the taste and texture of the final product. After being filled with sauce or vegetable oil, the mackerel cans move on to a critical stage: cooking and sterilization inside a large industrial retort. Inside, the temperature reaches 121 degrees Celsius, with pressure levels so high that the cans could deform if not precisely controlled. Over 45 to 60 minutes, the fish is fully cooked inside the sealed container. The flesh becomes tender, the flavor penetrates deeply, and all bacteria and spores are effectively eliminated, allowing the product to be safely preserved for long periods without the need for artificial preservatives. Few would guess that crab sticks, those familiar orange-red strips on sushi trays, actually began as a response to a surplus crisis. In 1960s Japan, soaring fish catches flooded the market with low-value species like pollock and threadfin bream. To save the fishing industry, Japanese food engineers invented an artificial crab meat, made from surimi, minced and refined white fish. And with just a touch of red coloring to mimic crab leg meat, the world was convinced. If Japan was the birthplace of crab sticks, then the United States became the grand stage that launched them to global fame. Every year, Americans consume over 100,000 tons of crab sticks, making them a staple in more than 60% of packaged sushi trays, seafood salads, and ready-to-eat meals from New York to California. Compared to real crab sticks cost 5 to 10 times less, making them the perfect choice for anyone craving crab without breaking the bank. Though just an imitation, the value of crab sticks is anything but fake. They're convenient, easy to store, protein-rich, and ready to eat straight from the pack. And every journey has a beginning. For crab sticks, that adventure starts in the frigid Bering Sea, where ice still clings to the surface even as spring arrives and Arctic winds howl through day and night. It is here, in these harsh waters, that pollock and threadfin bream, the two primary ingredients, are harvested amid crashing waves and freezing mist, marking the start of a remarkable transformation from deep sea to dinner plate. Unlike sardines that gather near the shore or tuna that hide in the warm depths of tropical oceans, white-fleshed fish like Alaska pollock and threadfin bream swim in massive schools in the midwater and bottom layers, at depths beyond 300 meters where sunlight no longer reaches and human eyesight becomes useless. But humans don't stop at the limits of vision. Today, fishing is no longer a game of luck, it's a battle of technology. On deck, experts monitor sonar screens and high-frequency echo sounders. When the signals appear, thick color bands drifting across the screen like clouds beneath the ocean, the captain gives the order to drop the net. The midwater trawl, a gigantic net with an opening hundreds of meters wide and as tall as a 10-story building, is released, expanding like a colossal funnel in the heart of the ocean. In just minutes, hundreds of tons of white fish, from shimmering silver pollock to pinkish threadfin bream, cascade onto the deck like a living waterfall. Their glittering scales reflect the floodlights, turning the ship's deck into a glowing burst of life in the dark sea night. But this is not an endless harvest. Every ship carries an independent observer, specialists tasked with meticulously recording every single fish brought aboard. From total catch weight to the proportion of juveniles, male to female ratio, and even the unintended bycatch, everything is documented and sent to the Central Fisheries Management Center. Because in the modern world, fishing isn't just an industry, it's a commitment to the ocean. A long-term contract between humans and the sea, where profit, livelihood, and conservation must walk hand in hand. Break this agreement, and the price may be the disappearance of a life source that has sustained us for centuries. The moment the net is hauled up from the depths and the first fish hit the deck, the race against time begins. On modern factory ships, fish are not left piled up waiting to be processed. Instead, they are immediately rinsed with clean seawater and transferred into chilled storage holds, filled with ice at temperatures close to 0 degrees Celsius. This thick layer of ice doesn't just prevent protein breakdown, it also inhibits bacterial growth and slows oxidation, the silent threats that can ruin an entire haul in just a few hours. This cold buffer step is crucial, preserving the fish's freshness before it enters the onboard processing line. After being chilled on board with crushed ice at temperatures near 0 degrees Celsius, the fish are quickly transported to land in insulated containers, ready to enter the processing phase at the factory. Next, the fish are poured into large stainless steel washing tanks, where the cleaning process begins under strict temperature and hygiene controls. Here, High-pressure spray systems use seawater or chilled freshwater, kept below 5 degrees Celsius, to rinse off the slime, sand, fish scales, and any remaining impurities from the surface after their long journey from the ocean. The water pressure is strong enough to remove contaminants, yet gentle enough to preserve the delicate structure of the fish flesh. This step is critical in stabilizing quality from the very beginning, preventing cross-contamination, and ensuring the final surimi reaches its highest level of purity. Processing steps, including skin removal, cutting off the head and tail, and removing all internal organs, leaving only the pure white fillet, rich in protein and low in fat, which serves as the primary ingredient for surimi production. However, even though machines handle most of the rough processing, one critical step remains that automation cannot replace: manually removing tiny bones under a backlit inspection table. Workers use specialized gloves to carefully inspect and extract each small bone by hand. This is a vital quality control step, ensuring that the raw material entering the grinding phase is as pure as possible. Next, after the fish are filleted, the white flesh is sent directly into a high-capacity grinding system, the starting point of its transformation into a standardized industrial ingredient. Here, the grinder, the core machine of the production line, operates non-stop, processing hundreds of kilograms per hour and several tons of raw material per shift. Have you ever wondered why fresh pollock or threadfin bream has a pale pink color but turns bright white after grinding? That's because this process doesn't just shred the flesh, it also continuously washes it, removing blood, oils, and fishy odors, leaving behind only the purest protein. The result is a smooth white surimi block with no smell and no flavor, ready to become crab sticks, fish cakes, and more. Each hour, the system can process 2 tons of fish, up to 40 tons per day. That means within just a few hours, fish freshly pulled from the ocean are transformed into pristine white raw material, ready to enter the global food industry. After being ground and thoroughly washed, the smooth white surimi is transferred to a mixing tank and combined with about 2 to 3% salt. Salt not only draws water out of the muscle fibers, but also helps unlock the protein structure, making the protein chains more flexible and capable of forming strong bonds. Once mixed, the surimi is precisely portioned using an automated weighing system and packed into stainless steel trays or specialized PE bags, designed to withstand low temperatures and prevent moisture absorption. This packaging process takes place in a chilled room below 10 degrees Celsius to inhibit microbial growth and prevent heat-induced protein denaturation. Immediately afterward, the packed surimi is transferred to a deep freezer at 30 degrees Celsius for rapid freezing, which stabilizes the protein structure and secures the mechanical bonds within the fish flesh. This is a technically advanced preservation step that ensures the surimi retains its moisture, avoids protein degradation, and maintains high quality until it reaches the crab stick processing plant. Rate of up to 1.8 kilograms per day, nearly twice as fast as conventionally raised pigs. Their diet consists primarily of corn, wheat, and supplemented vitamins, designed to develop the ideal belly fat composition needed for high-quality bacon, with even fat marbling that delivers perfect crispness and rich flavor. Interestingly, some bacon-dedicated farms even incorporate beer into the pig's feed. Adding beer to their diet helps produce more evenly distributed and higher quality fat, almost as if the pigs themselves are savoring a taste of flavor before transforming into bacon. After about 6 months of rearing, when the pigs have reached their ideal weight of approximately 110 kilograms, they begin their final journey from the farm to the processing plant. Before being loaded onto the transport trucks, the pigs are lightly washed using cleansing or disinfecting solutions. This step helps remove dirt, bacteria, and pathogens from the surface of their skin, reducing the risk of cross-contamination during transport and at the plant. Handlers use specialized tools such as mobile panels or soft paddles to gently guide the pigs. The walkway from the holding area to the transport truck is specially designed with a low incline, allowing the pigs to move easily without losing balance. High side barriers are typically installed along the walkway to limit external visibility and prevent the pigs from becoming distracted or startled by sudden noises, lights, or movement. Inside the truck, each tier is often lined with a layer of rice husks, sawdust, or other absorbent material. This not only provides better grip for the pigs, but also helps absorb moisture and maintain hygiene, making post-trip cleaning easier. The transport vehicles used are specially designed livestock trucks, usually multi-tiered to maximize space while maintaining ventilation and comfort. They are equipped with ventilation systems, shock absorption mechanisms, and often sensors to monitor interior conditions. These features help ensure that the pigs are transported in a safe, comfortable, and low-stress environment. The entire process from loading to transport requires not only technical expertise, but also strict adherence to animal welfare standards, hygiene protocols, and food safety regulations. Before entering the slaughtering process, pigs are taken to a designated resting area for a final health inspection. This stage is critical to ensure that the meat products, especially bacon, meet the highest food safety standards. Pigs are guided into a specialized washing area where their entire bodies are sprayed with clean, high-pressure water to remove dirt, mud, and waste residues from their skin. Following this preliminary rinse, they are lightly sprayed with a mild disinfectant solution, typically safe compounds such as lactic acid or low-concentration chlorine, to eliminate bacteria and pathogens present on the skin's surface. Once cleaned, the pigs are transferred to a high-capacity cutting machine. Here, they are precisely and quickly cut in half using sharp blades, ensuring that the meat remains intact and undamaged. The cutting machine uses advanced technology and automatic control, making the cutting process smooth and uniform, optimizing the use of raw materials. After being cut in half, the meat parts are transferred onto a conveyor belt. Here, they are further divided into specific parts, such as lean meat, fat, ribs, bones, and other sections. The sharp saw blades, combined with laser technology, make precise cuts, ensuring that each piece of meat is neatly separated without damaging its quality. The lean meat is cut into smaller pieces for fresh processing, while the fat, ribs, and bones are also clearly categorized, ready for the next stages of processing into various pork products. This entire process is carried out in a closed environment that meets food safety and hygiene standards, ensuring the final product is of the highest quality while minimizing material loss. During the meat separation process, the pork belly, also known as the belly cut, is singled out as the primary ingredient for making bacon. An ideal pork belly typically features a balanced layering of fat and lean meat, creating a unique texture when fried or roasted. Crispy on the outside, juicy and tender on the inside. After being cut, the pork belly is inspected either manually or using sensor systems to ensure it meets the standards for thickness, fat-to-lean ratio, and size. Pieces that do not meet the requirements may be redirected to other processing lines, while the qualified cuts proceed to the curing stage. Once the pork belly is ready, the seasoning process begins, starting a journey to create the irresistible flavor of bacon. There are two common seasoning methods: dry curing and wet curing. In the dry curing method, the pork belly is evenly coated with a mixture of salt, sugar, pepper, garlic, and natural herbs, creating a perfect blend of flavors from the very first touch. Wet curing, more commonly used in industrial production, involves soaking the meat in a special brine solution that combines salt with spices such as sugar, pepper, garlic, and natural extracts, ensuring the meat absorbs the distinctive bacon flavor. To ensure the seasoning is evenly distributed, a specialized injection system with dozens of small stainless steel needles is used. The needles are carefully positioned across the meat's surface, injecting the seasoning mixture precisely into each piece. This automated system works quickly and with pinpoint accuracy, allowing the seasoning to penetrate deeply from the surface to the core, creating a perfectly seasoned and uniform layer on each piece of bacon. This process not only ensures the flavor quality, but also optimizes the use of seasonings, resulting in a final product with rich, irresistible taste. Once the bacon has been meticulously seasoned, it enters the enchanting stage of smoking, a culinary wonder that transforms ordinary pork into an irresistible delicacy. The seasoned slabs are placed into smokehouses, where controlled heat and smoke from natural wood begin to work their magic. Depending on the type of wood used, oak, hickory, or even apple wood, each imparts a distinct character, blending smoke and seasoning into a harmonious flavor signature unique to each batch of bacon. Smoking times can range from several hours to up to 24 hours, depending on the method and the desired flavor profile. Throughout the smoking process, the meat absorbs waves of aromatic smoke, with each breath of smoke adding another layer of rich, complex flavor to the meat. After smoking, the bacon slabs are removed from the smokehouse and pressed to create uniform thickness, preparing them for precise slicing. After pressing, the meat, now true bacon, is fragrant, tender, and richly imbued with smoky flavor. Yet its journey isn't quite finished. Before bacon can grace supermarket shelves or star in delicious breakfasts, it must undergo the critical and meticulous slicing phase. Large rectangular slabs of bacon are fed into automated slicing systems, equipped with razor-sharp stainless steel blades operating at high precision. These modern machines slice each piece consistently and attractively, with the ability to adjust the thickness of each bacon strip to meet exact standards. Some advanced slicers can process up to 60 packages of bacon per minute, equating to over 3,500 strips per hour, dramatically boosting production efficiency while minimizing error. Packaging is the final yet equally important step in bacon production. After slicing, the bacon strips are neatly arranged and fed into modern packaging machines. Here, bacon is often vacuum sealed to remove air, helping to extend shelf life and prevent bacterial contamination. Depending on intended use, bacon can be packaged into convenient small packs for households or larger blocks for restaurants and supermarkets. The packaging is robust and clearly labeled with origin and expiration dates, ensuring that each slice of bacon reaches the consumer fresh, safe, and flavorful. Once the right conditions are met, farmers begin the delicate process of tapping the trees. A small hole, usually about half an inch in diameter and 2 inches deep, is drilled into the trunk of a mature maple tree. A spout, often made of metal or plastic, is inserted into the hole, allowing the sap to flow out. Traditionally, the sap dripped into buckets hanging from the tree, which had to be collected manually. However, modern maple syrup producers use a more efficient system of interconnected tubes that transport the sap directly from the tree to a central collection tank. This method reduces labor and ensures that the sap remains clean and fresh. The amount of sap collected varies from tree to tree, but on average, a mature sugar maple produces about 40 liters of sap during the harvesting season. While this may sound like a generous amount, it takes roughly 40 liters of raw sap to produce just 1 liter of maple syrup. This is because the sap itself contains only about 2 to 3% sugar, with the rest being water. The real magic happens during the boiling process, where the water content is gradually removed to concentrate the natural sugars. After collection, the sap must be transported to the sugar shack or processing facility as quickly as possible to prevent spoilage. In the past, sap was carried in wooden or metal buckets, but today, pipelines connected to vacuum pumps allow the sap to travel more efficiently. Once at the sugar shack, the sap undergoes an initial filtration to remove any debris such as bark or insects. At this stage, the sap still looks like plain water, but its transformation is about to begin. The next and most crucial step in maple syrup production is the boiling process. The sap is poured into large evaporator pans, usually heated by wood or oil-fired furnaces. As the sap boils, the water content evaporates, leaving behind a more concentrated sugar solution. The sap needs to reach a specific temperature of approximately 219 degrees Fahrenheit, 104 degrees Celsius, to achieve the perfect consistency. Throughout this process, the syrup's color and flavor develop, with lighter colored syrup having a milder taste and darker syrup carrying a stronger, more caramelized flavor. The boiling process can take several hours, and syrup makers must closely monitor the temperature and consistency to prevent burning or over-thickening. To speed up the concentration process, some modern facilities use reverse osmosis technology before boiling. This method removes a significant portion of the water from the sap before it reaches the evaporator, reducing energy costs and increasing efficiency. While this technology is helpful, boiling remains an essential step in developing the syrup's unique taste. Once the syrup reaches the desired concentration, it is carefully filtered again to remove any remaining impurities. A common byproduct, called sugar sand, forms during the boiling process and can give the syrup a gritty texture if not properly filtered out. To achieve a smooth, high-quality syrup, producers pass it through fine filters made of felt or paper before transferring it to storage containers. After filtration, the maple syrup is ready for packaging. It is poured into sterilized bottles, cans, or jugs while still hot to ensure long-term preservation. Syrup must be bottled at a temperature of at least 185 degrees Fahrenheit, 85 degrees Celsius, to prevent contamination. Once sealed, the syrup is ready for distribution, reaching consumers around the world who enjoy it on a variety of dishes. The grading system for maple syrup classifies it based on color and flavor. The lightest syrup, known as golden, has a delicate taste and is typically harvested early in the season. Amber syrup, which is slightly darker, offers a richer flavor. Dark syrup has a strong, bold taste, while very dark syrup, the last to be collected in the season, has the most intense caramelized flavor. Each type has its unique appeal, and consumers choose based on their personal preferences. While pure maple syrup is the most well-known product derived from maple sap, there are several other delicious variations. Maple sugar is made by boiling syrup even further until all the water evaporates, leaving behind crystallized sugar. Maple butter, despite its name, contains no dairy and is made by whipping thickened syrup until it forms a creamy spread. Maple candy, another popular treat, is made by pouring hot syrup into molds where it hardens into sweet, maple-flavored pieces. The production of maple syrup is not just a business, it is a tradition passed down through generations. In Canada and the northeastern United States, maple syrup is deeply rooted in local culture and history. Indigenous peoples were the first to discover the process of tapping trees for sap and boiling it to create syrup. European settlers later adopted these techniques, refining them over the centuries. Today, maple syrup festivals celebrate this seasonal tradition, bringing communities together to enjoy fresh syrup, maple taffy, and other treats. Despite its deep historical roots, maple syrup production continues to evolve with modern technology. Improved tapping techniques, better filtration systems, and energy-efficient boiling methods allow producers to create high-quality syrup while preserving the health of the trees. Sustainability is a key focus as responsible syrup makers ensure that trees are not overtapped and that forests remain healthy for future generations. And the sweetness of nature is endless.